First of all, I'd like to thank Andrew Ross, Location Tech, and Eclipse Foundation for this exciting opportunity. And today I'm going to talk about perhaps the most important project in my professional career so far, a project I put a lot of care, a lot of enthusiasm into, and this project is Leaflet, an open source JavaScript library for interactive maps. So let's start the presentation. First of all, I'd like to introduce myself a bit. You can read a bit about me on agafonkin.com. I live in Kiev, a beautiful city in Ukraine, and English is not my native language, so I apologize for any hiccups I may have. And I work as a front-end architect in Cogniant Software Consultancy for the CloudMate project. And I have written many tens of thousands lines of JavaScript, HTML, and CSS code for their services. And I'm also a big open source enthusiast, and I do some fun stuff on GitHub, and you can check out my other project there. And I'm also a musician, but that's a different story. You can download our album on rain.in.ua. Okay, Leaflet. Leaflet, a JavaScript library for mobile-friendly interactive maps. You can read everything about it on leafletjs.com with tutorials, examples, demos, etc. So if you ever used maps on websites, I think you know how such library can work and look like. So basically, you have a map, you have a way to, one moment, I'll switch to the demo. Okay, so you have a map, you have a way to interact with it, pan it around, you can zoom it out, zoom it in, and do different kinds of interaction with it. You can put some stuff on the map like markers, vector features, pop-ups, and that's that's not much more than this. So the library is quite simple, actually, and I could have just go through the set of features of this library in this presentation, but I think it's kind of boring. Live talks are created for expressing some important ideas, for maybe inspiring something, sharing ideas. So instead of just going through the features, I'm going to talk about the main ideas behind the library, so that you could understand it better. So the library is quite basic in the set of features, but it's the approach it takes when implementing those basic and a set of guiding principles it takes, what really makes it different and what I believe enabled this library to become such a great success in such a short amount of time. So if you look at the history of online maps, the first one to appear was Google Maps API in February 2005. That's more than 7 years ago. A year later, OpenWares appeared as an open source alternative, and in 2009, Google Maps API released version 3 that it claimed to be much lighter, much faster, much more optimized for mobile devices, and etc. And only in May 2011, Leaflet gets its first release, so that was just 1 year and a half ago, and it pretty much gains mainstream acceptance and perhaps becomes #1 open source library for publishing maps on the web. And to support my claim about the success, I'll show you some of its big users. Leaflet is used by Flickr, my favorite photo hosting website, by Foursquare on its website. It's used by Wikimedia Foundation for the official iOS and Android applications of Wikipedia. It's used by Craigslist in US. It's used by a whole bunch of news media websites like the Washington Post, Boston Globe, Los Angeles Times, etc. It's used by perhaps the biggest game portal over the whole internet, EGN. It's used by lots of national services like USGS, and of course big amounts of other companies, startups, and that's just the tip of the iceberg. And I'll show you some example uses. So this is how it looks on Foursquare. You have a simple map, some markers, some pop-ups. That's nothing new. This is how it looks on Flickr. That's not surprising either. But actually, Leaflet is used not only for usual maps, but also in some other interesting applications. So this is an example of data visualization. It's the results of presidential elections in US on Washington Post. It's interactive visualization that's also powered by Leaflet. And the next example is quite interesting too. It's actually not a real world, but a map of an interactive map of Skyrim game world. So it will be of interest for RPG fans there. And here's a map of World of Warcraft. So basically quite a lot of different use cases. And you may know that OpenStreetMap.org just a couple of weeks ago switched from OpenLayers to Leaflet for its website. That's quite a nice achievement too. So, and one more example that's not even a map. It's a high-resolution screenshot of a battle in a Total War game on the official website. So it allows you to browse high-resolution image, zoom in and out like you would for a map. Okay, so there are a lot of great uses of Leaflet, despite it being quite a young library, and the trend is going upwards. So it's quite impressive to see more and more users and contributors every day. And I would like to explain the main ideas and core principles I took when creating the library that enabled it to achieve such amount of success. So the first point is not surprising, but I should talk about it a bit. It's open source. So a JavaScript library in general that's not open source in modern time is a nonsense. It's really unlikely, and you can't expect any JavaScript library that's not open source gain any kind of acceptance among developers. But surprisingly, it's not like that in the mapping world. So Google Maps API is, despite being a JavaScript library, it's closed source. Its source is obfuscated. So companies that use Google Maps for their maps, if they have some critical issue they want to fix and they may put their own resources to fix it, they can do it because they can do anything with the code. And perhaps if you want to build some really amazing things on top of the library, it's also very difficult because you can't study the internals of the library. You can see how something is implemented inside to be able to build upon this. So you can't go beyond the basic examples that you see on the website and documentation. So that's criteria for successful library. But it's just being open source is not enough, of course. So I'll go through a bit of stats of the project that I was publishing on GitHub. So over 2 years of development, there were a bit more than 8,000 lines of code written, and that's quite a little amount of code for such a library. And there were almost 2,000 commits from 90 people, and that's actually quite an impressive number for such a small project like this. So realizing that 90 people all over the world that I don't even know personally independently decided to help the project, to send me some improvements and help fix bugs. It's just amazing because Leaflet's initially started as a one-man effort, and having such a great number of contributors is really impressive. And it has a lot of followers and forks on GitHub. It has more than 1,000 issues closed and more than 340 pull requests or patches merged or closed on GitHub. So the amount of activity going on is quite high. And how I was able to achieve this is, if you look at maybe, for example, 5 years ago, if you are an average developer that wants to contribute to some project that you like, there's actually a really big barrier between you and the project, because it's very confusing to start. It was very confusing to start contributing to a project. There were a lot of steps involved in this, and so people just didn't know where to start. So I was like this. And in modern open source world, everything is really simple as it can be. So for example, for Leaflet and GitHub, you can browse the source of the library and maybe you decide to improve something. You don't even have to know Git or have a command line set up. You just open a file source in the browser and hit edit. And this is it. So it can be made simpler than this. And this simplicity, it enables so many individuals that otherwise would be afraid to try to become a contributor of an open source project they like, to help the project with their code. And for me, as a maintainer, as a library, the process is as simple. So I see the patch coming in, and I review the changes, and I can just click merge one button, and it will be automatically merged in the project. So now I'm not just talking about GitHub, so there's an overall tendency of this kind of workflow and becoming more and more simple. So simplicity is a key, is the most important key in getting people to become contributors of open source. And so this was a key factor in Leaflet's becoming what it is now. So the next point is independence. Independence from data providers. So Leaflet actually doesn't have a single line of code that's related to a particular provider of data. So many companies that want to use the library for their own uses, perhaps using their own data, they are not hesitant to commit to supporting and contributing to the library because they are sure that it doesn't get influenced by commercial providers. It is based on open standards, and so they may contribute to it no matter what data they use, and that was one of the selling points too. So Leaflet, despite using CloudMate tiles in the examples, it still states and positions itself as a service agnostic library, and that's why so many companies decided to put some effort contributing to it. The next point is perhaps the most important one to understand. This is related to features. So in this screen you see an example list of features that such library for interactive maps could have implemented. And this list is actually not complete. I could go on for several more screens like this. But I realized that if I'm going to try implementing all those features in such a library, I won't be able to focus on making the stuff that's really important, making it really great. So I decided to take a different approach and pick just the most basic, the most essential, the most important features that interactive map library should have, and focus on quality instead of quantity and just number of features. So this helps me keep myself focused and to work more on the quality, to work more on what's important. And this actually it's important to that it is small. The code base and the model, that the architecture of the whole library is small enough for me to keep in my head, so I can control it, I can easily improve it, and not worry about everything else. And I also put a lot of effort into making it as extensible, as flexible as possible, so that third-party plugin developers can build some really amazing, awesome things with it. And Leaflet now actually has quite a powerful plugin community. So we have a list of plugins on the official website, and there's a new plugin almost every day, and some plugins are really powerful. So one example being a marker clustering plugin. That's actually, I think, the most impressive marker clustering solution I've ever saw among all mapping applications out there. So it has beautiful animations. It's really fast. It has great features like this. So and I can keep focusing on the core while another great developer, in this case Dave Lever, focuses on uh, making the plugin really great. Uh, and this is quite a, quite a nice approach. So it's helped me a lot with achieving such level of quality of library in general. Um, so the next point is simplicity. Uh, and this is a value that that's, I think, on top of all other values uh, when thinking about writing code for the library and everything else. So, for example, when it comes to API, I try to make it as simple as it can possibly be. If you look at example code, uh, every line of code, every statement does one clear action, and every action then you can make uh, with the API, it can be made using really simple statements. So here you create a map with l.map on a map div, and you set the view to particular coordinates and zoom level. You can create add a tile layer to the map with one line of code, creating a tile layer, giving it an URL of OpenStreetMap tile, for example, and doing add to map. It adds it to the map. So, and when you want to add a marker, you do a marker with the coordinates. You do add to map. You you can bin pop-up to it with some content and open pop-up immediately. So it's really simple. It's very readable, and a lot of effort was put into designing and this kind of API that is as simple as possible. So simplicity is a measure value for Leaflet, and uh, the code is very simple outside for Leaflet. I mean the API, but it's also really simple inside. I mean the internals, and this was also critically important for Leaflet to achieve such a great number of contributors. Um, because the first thing a developer does when he wants to contribute something is he opens the code of the project and reads it. And if it's too difficult to understand, if it's not simple enough, he will simply be afraid to go further and contribute something. So he will be afraid that he will spoil something in the code. He will be afraid to do something wrong, to do something not in a way that's supposed by the library, and he will often just not understand how to do something. So uh, uh, the simplicity of codes means more contributors. So the simpler the code, the more contributors it has, and the number of contributors for Leaflet reflects that. Um, and when talking about writing simple codes, a very nice association that I like personally is poetry, because poetry, by definition, is expressing deep meaning through simple words. And it is a lot like that for code, because you need to do the same. You need to write short, simple, readable, understandable sentences that do what you want. And one more uh, example that demonstrates this principle of simplicity is when I see some code needs a comment to explain what is happening here. It actually doesn't mean that that's the lack of comment that is bad in this case. It's actually the code that is not clear enough, not transparent enough, not simple enough, and that's why it needs a comment. So in such cases, it's always better to rewrite the code to be simpler, to become transparent, than to add comments to it. And this is quite contrary to position among many developers. Then that the more comments in the code you write, the better developer you are. So in case of Leaflet, and when you value simplicity of code, that's actually quite the opposite. So backwards compatibility is another holy grail of software development that is put a lot of effort and thought into, and I decided that spending too much on backwards compatibility will harm the project a lot more than it will do good. So I decided to go with another approach. I decided to go full throttle. So concentrate on continually improving the API. So no matter that if there is a chance that I can make some method, some call, something in the API better, simpler, I will do that no matter if it breaks backwards compatibility or not. Of course, I won't do that in minor version release, but for major versions, I will add as much API improvements as I can to make the library better overall. And making library better is much more important for me than keeping backwards compatibility. And this is not as harmful as it would be if I didn't document it well. So the key factor here is documenting every change of the API really well, not just changing the reference, but also writing examples that will help people convert from a previous way of doing things to a new one. And if everything is well documented and with lots of examples, backwards compatibility won't pose much of a problem. So it's better to focus on improving. Next point is browser support. If you look at the most common approach to browser support in web applications and websites, typically the most effort goes into supporting modern browsers first, and then a lot of effort and a lot of painful time spent on making legacy browsers, like for example Internet Explorer 6 or 8, behaving the same way as modern browsers. So the functionalities and the looks are the same. And mobile support is usually added as an afterthought, so it's not very complete. It's just there to just a bit of it, but not much. So this approach to browser support is irrelevant in modern development. And with Leaflet, I decided to go with a different approach, and that's making modern browsers and mobile browsers on the same importance level. So I put a lot of time making experience on mobile phone as smooth, as fast, and maybe even better in terms of user experience than on modern desktop web browsers, because mobile phones like iOS, Safari, like Android browser are much more advanced than legacy browsers were, and so they can do a lot of things, and they are as capable as desktop browsers now, and so many uh, people neglect this. So and regarding legacy browsers like IE, um, I usually spend time on it to the point until it is accessible. So, for example, if we have a pop-up with rounded corners and pretty shadow and perhaps gradient, uh, if it looks not like this in IE6, it will be pretty much okay. So if the pop-up will be just a rectangle with a border, uh, the user will still be able to get the information he wants. So it will still be accessible. Uh, so I won't spend a lot of effort into making the pop-up look the same as on modern browsers, because it's just not worth it. The energy is better spent elsewhere on leveraging the modern web technology advancements, and legacy browser support should be made accessible and not more. Okay, so next point is making the library uh, the most lightweight, responsive, and fast library out there for maps. And if you look at the size of the library, uh, here are some stats. So JavaScript code weighs about 27 kilobytes of code, minified and compressed, and that's a tiny amount of code. And some people say that size is not very relevant nowadays, because we have broadband channels, and images like tiles are weight much more than the whole library, so why bother making it small? But from performance point of view, uh, mobile, for example, mobile browsers, they not only need to download the JavaScript code, they also need to evaluate, to execute it, to put it into its memory, and etc. So the more code you have, the worse performance will be, and this is especially the case on mobile browsers. So the less, the better. And due to my approach to browser support, uh, where I don't put a lot of effort making everything look the same on all browsers, but instead focusing on leveraging browser abilities, I was able to take advantage of modern web technologies. So HTML5 and CSS3 features are used quite extensively in Leaflet. They are used where in browser that support them, and the map is still accessible for all browsers that don't. But for most people that use modern browsers on both desktop and mobile browsers, the experience is the best they can get, thanks to the technologies used. So I was able to achieve a really great performance and hardware acceleration of animations, a really smoothness of all things due to using things like CSS3, transforms, transitions, things like request animation frame API, and etc. So leveraging new technologies, even if they are not even if they don't have a wide browser support, they can still be used today to improve the experience of users. Uh, Also, having a math background in university, I spent some time in making optimizing bottlenecks of performance in the library using algorithms. And this one example of math algorithms being used very effectively in Leaflet is Simplify. Simplify JS is actually a really small library that I extracted from Leaflet that does geometrical simplification of vector features. So here on this demo, you can see that we have a root consisting of more than 70,000 points, and they are simplified into a bit more than 100 points without sacrificing visual looks in 1 to 2 milliseconds. That's really impressive, and this is one small part of making Leaflet so fast and so responsive. So it does real-time simplification of vector features on each zoom level. Just an example. Okay, so next point is that design matters, and design matters as much as code, if not more. A lot of people behind great open source projects and great technical advancements, great solutions neglect the design part of the work. So there are a lot of products that may be brilliant, that may be implemented just amazingly, that have amazing technology, amazing implementation, but they are presented not in a good way, and so they fail to get to their users. So I spent a lot of time on making the website, making all parts of Leaflet presentation, from READMEs, documentation, everything. Look nice, look simple, look accessible, and this really helps Leaflet adoption. So many users like that on the first glance, and they decide to spend with library more time. And this not only concerns the website. So a lot of effort was put into making the API reference very nice to look at, and if it's designed well, users will be able to learn the library and much more enjoyably, and it will help with getting more users and more contributors. And the last point I wanted to make is Kaizen. So Kaizen is a Japanese principle that basically states that small improvements over small regular daily improvements, when doing them over a long period of time, they add up to something really great. So I'm a big proponent of this principle, and I use it in Leaflet. And examples are, one example is that I may spend 2 hours tweaking a value of opacity on a shadow of zoom control, and I will find the perfect value so that it looks uh, the best way, and users will probably not notice the difference. But if you make such differences every day and make hundreds of such improvements over the course of development, it starts to be noticeable a lot, and this this makes library more and more perfect every day. And another example is that sometimes when I don't feel like fixing some known issue or implementing some new feature, I may just sit and start reading through the leaflet code randomly. And if I see that something is not very comprehensible, and maybe I can rename some variable to be simpler and make the code a bit more understandable, I will do that. And this small improvement, if done over often, it makes the library really uh, great in the end. So basically, that's all I wanted to talk about. And now I'll switch to any questions you may have. So let's take a look. Um, I see that there are no questions right now. Uh, oh, Andrew will write something. Uh-huh. Okay, no questions. Excellent. Thank you for listening, and feel free to ask additional questions in Twitter, in the Google group, or everyone, everywhere where you find suitable. And thank you for listening, and see you.